Okay.
And you'll switch when?
Back, yeah, switching you mean the slides and stuff like that?
Yeah.
Yeah. And is it showing?
No, I can't see the slides.
You can't see the slides?
No, I see you.
You see me. Hold on. 1 second. Screen share. Come on. What about now? Still just me?
We'll pull up the slides. Yeah, we did the slides now.
Oh, sweet.
Okay. All right, so I'll do a quick intro and we'll start. Okay, so we'll get started a little early today. We scheduled this for 10:15 as opposed to the typical 10:30, so hopefully a lot of people will come in. I guess some new faces, so we'll do a quick round of introductions maybe after this presentation. But so this is Ian Craig, one of my students at San Francisco State. I teach here in information systems. We spoke with Invenio some time ago about all the different kinds of solutions that are out there in this so-called microserver space, which is tiny servers that can run on batteries and solar panels and such in the middle of nowhere, give you limited Wi-Fi and so on. And one of the big questions is, when you take something like this to the field, how many clients can it support? And if you think of it, it's a problem that's got multiple variables. You've got a constraint on power supply, because you have to figure out how much power is available there and what you can provide steadily for this device. Maybe a battery, a solar panel, a combination, the local grid. So that's one constraint. The other constraint is obviously then based on power, you want to maximize on all the resources you can provide in the server. So you want to have lots of CPU cycles, you want to be able to have lots of disk input, output, and those kinds of things. So it becomes one of those things where you have to find the sweet spot, or several sweet spots, where within the given power supply, you can provide the best possible flow of information for that particular neighborhood. So we got talking, and then we figured this was something that cannot be just done in a week or two. So that turned into an internship with Ian and another student who's not here today, Satara. And they worked on this for a semester.
Yeah, for about 4 months or so.
4 months or so, and then it grew from being just one device to multiple devices, and kind of looking at what those offer. So anyway, this is the conclusion of that. And the report is largely done. We've got some more finishing touches, so then that'll be up online at olpcs.org. But yeah, Ian's going to talk through what he's done and what they found, and hopefully that'll be useful for not just us, but a whole bunch of other projects. So,
perfect. So as you said, I actually had a partner with me this whole time. Her name's Satara. She wasn't able to be here today, but she helped me research a lot of these solutions. So basically, as Professor Verma already pretty much said, he set up an internship with us in Invenio so that we could study all these different solutions that they were looking into. So today I'm going to go over essentially what we did for Invenio, which we covered a bit already, but the solutions we tested and what our methods for testing were to load test these microservers, and what the results and our final conclusions were about all the different options that we looked at. Okay, so yeah, internship was set up through Professor Verma. I've been a student of his actually for a while. I took a few classes from him, and he always showed us OLPC videos in the beginning of class, and I always found it fascinating, and I was really into it. I think education should be spread as far as it can be spread, especially to developing countries. And with the way technology is coming, these small little devices are perfect to bring wherever you need it, even if you don't have internet. So originally, we were asked to test a Raspberry Pi device using Rachel software, which is made by an organization called World Possible, if nobody's heard of it. But, and that is something that Bruce, the executive director of Invenio, is on a board with World Possible. So they have a connection, basically, and that's, I guess, why we were looking at Rachel mostly. In the end, we ended up testing three solutions. But as I said, we were going to focus on Rachel, but we did Rachel, something called Library Box, and Intel Education Solutions. So originally we load tested, and we got results for 3 solutions, but we researched about 7 different ones. Widernet, Internet in a Box, Library for All, Outernet, all these different options are all just different ways to basically have a microprocessor become a hotspot and give out some type of content. Some were more expensive than others. For example, Outernet requires a satellite connection, so you actually have to buy a mini satellite to stay connected with their satellites, and sometimes it's available, sometimes it's not. So essentially we used a weighted scoring model to, after doing all the research and finding out all the different things about these different solutions, we basically based our scoring method on the ease of use of each option. So the ease of use, the power, updatability, the information available to us on the internet, support from the provider or the developer of the product, the content that was available, cost, whether it be high or low, and whether it's mobile capable. So if you actually need to have a power outlet, or if it can be solar powered or through battery or something like that. So this is actually what we came up with. There's a lot, some of this I'm really going to kind of skip over pretty quickly and just focus on what we really did, which was, again, Rachel Library Box, and the Intel Education Solutions isn't on here because it wasn't even thought of at first, and I'll go into that in a second. But basically, this is the weighted scoring model. Essentially 10 being ease of use, super easy to use. You know, you don't really need any training on it. You can just plug and go, and it's ready to go. And one more thing to kind of explain, like power. So like a 10 would be, you know, it has its own battery pack, and a 1 would be, you know, you really need an outlet and constant power for it to work. So we came up with essentially that we wanted to look at Rachel and this thing called Library Box. And we were also, this one down here, Commonwealth of Learning, it scores a little off. It should be an 8.35. And a couple things needed to be changed there in the end, because something that we really based it on was how the developers of these solutions contacted, or how they contacted us back and forth. So we tried to email a lot of the creators of these different solutions, and many of them weren't able to, many of them didn't even respond, and many of them did. Commonwealth of Learning, we got 1 response from them, and they essentially told us that their solution for a digital library is not really up and running just yet, and that they are getting donations, and it's kind of a Kickstarter project from what I fully understood about it. So we didn't delve too much more into the Commonwealth Learning. Let's see. So, Professor Verma introduced me into a program called JMeter. It's an Apache program, and you can get it for free, and it's used for load testing for a lot of different devices, or a lot of different servers, whether it be a micro server, a regular computer server. Essentially what we did was we took work from another student of Professor Verma's named Benjamin Tran. I guess he did some OLPC work where he was load testing the OLPC devices. And we took some of his test scripts. He has all of that available online, and then I have some links to it in the presentation as well. But we took some of his test scripts, because that's what JMeter uses, and we basically imported them and adjusted them to work for us. So these scripts basically had IP addresses, and we would put, let's say we were using Rachel, and its URL was 00000. So we would put in the server IP address the specific page we were looking at. So for example, Rachel, it has a ton of information on it on a little SD card. Basically, it has a ton of Khan Academy, Wikipedia, all kinds of different things on there. And we would just, if there was a page we wanted to look at, whether it be about geography or history, we'd put that URL in our object reference for JMeter, and then we would be able to simulate requests going towards the server and kind of like overload it and see when it would fail, and how many devices could essentially be attached to it at once. So that's what the load testing was. What we focused on, we got a lot of statistics from it, but what we really focused on was the failure rate. So if I were to try to get to this page on Rachel about history, would it let me connect, or would it give me a server error or something like that? And that's what we were looking for. So the first solution we really focused on, again, Rachel, made by World Possible. It uses a Raspberry Pi device. We used mainly Raspberry Pi 1, but there's the Raspberry Pi 2 out now, and we did compare load testing between the two, and it actually wasn't that much different. I know it has a much faster processor from what I understand on the Raspberry Pi 2, but and I didn't include the screenshots for the failure rates for it, but it was like different by a couple %, so we didn't really think it was too important whether you got the first one or the second one. But it's cheap. It's one of the cheapest options we looked at. I mean, if we went in everything we needed, it would be a Wi-Fi dongle. We'd have to plug in a Wi-Fi dongle to make it a hotspot so that you could connect to it. You'd need the Raspberry Pi server, and then you would also need some type of power outlet and a flash drive or micro SD card. So essentially, you really could get all of that for around 60 to 80 bucks and have a tiny little device that will have all of Wikipedia, Khan Academy, and all types of information on it, just depending how big your flash drive is. So what we did, a couple things to explain here. The requests are supposed to be simulations of us trying to get to the specific page. As I said, trying to get to like a page on geography or history or something like that. And realistically, 1,000 people are not in a school in rural Africa or anything like that are not going to be, there aren't going to be 1,000 people doing requests. We're not going to overload the server that way. Where the bottleneck really came from was the Wi-Fi dongle you chose. So depending on the hardware you get, we used, I honestly can't remember the name. It was just given to us by Invinio, but it was a tiny little Wi-Fi dongle that just plugged right into the Raspberry Pi device. And the way we tested that, we didn't even use JMeter. I happen to work for AT&T as well, so I just used a ton of the phones we had at work and tablets and just connected it to this device, and we saw that it started to fail after about 10 devices or so. The bottleneck was really the Wi-Fi dongle. But processor-wise, like what the Raspberry Pi device could handle, these are basically the failure rates we got. So what we're looking here is, this is just a simple wiki page. If I were to go to Rachel's website, the first thing that comes up is options about Wikipedia and what I want to look at, whether it be geography, history, all these different things. And then there's algebra lessons, there's medical lessons, there's typing lessons, ebooks that you can read, all kinds of stuff. So with 1,000 requests going to it and a 60-second ramp up, meaning that over the period of 60 seconds, we expect this many requests to go through. And the reason we chose 60 seconds is because if I asked all of you to go to, Wikipedia right now, it wouldn't all happen within 5 seconds. It would take some time for everyone to get there. So within that period of time, with 1,000 requests, our average failure rate was only 2.3. And we decided that we were willing to go with a failure rate of about 5%. So meaning basically, one in every, spacing, 5%.
1 in 20.
I know, thank you, it's the morning. 1 in every 20 people would not be able to get to the page. That's kind of a high failure rate. I mean, if we had just like double the amount of people in here, one person would have trouble connecting each time. So, but again, where we really saw the issue come up was the bottleneck on the Wi-Fi dongle. But there were apparently Bruce and Invinio, the Invinio team, they looked into other Wi-Fi dongles that were available and different routers that you could get that could handle so much more. It could handle up to 100, 500 people on it all at once. We didn't even get close to working with that. But I wanted to compare it here because if we look at the two differences, here we just doubled the requests. We were just trying to overload the server, see what it could handle. And we see the difference between 1,000 requests. The average is a 2.3 failure rate. And then when we double it, we get up to 17%. So that was way too high. So we know that we can't have too many people on the device no matter what, processor-wise. Realistically, as I said, you can have about 10 to 12, but when it comes to actual people trying to get to the server, you could have up to 1,000 with an acceptable error rate, in our opinion.
Can you imagine 1,000
people?
requests?
Exactly. And you'll see, as I get to the other devices too, we actually had to pull that number down because other devices couldn't handle it. And ironically, when I get to the Intel Education Solutions, which is the most expensive package, it could handle the least amount of people on it, so which was kind of interesting. But so
is there a good correlation between the number of requests and number of people?
Just explain that to me. What do you mean?
Well, I'm assuming that if you try to get to a website, it may involve more than just one request, or is it?
Yeah. So, well, what we were doing here is
There's number of clients correlate with the number of requests? Is it a one-to-one or is
It is. I don't know. How would you answer that? It's a one. It's not a one-to-one.
Most of these is one-to-one.
Is it? Okay, so it's like yeah. From what we saw, it would be one request would be me sending a request to that specific IP address and trying to get information back for it. So yeah, I guess it would be one-to-one.
So I guess for our purposes here, we'd be much more interested in what kind of results you got for 100 or less.
Yeah. Well, 100 or less, we would get 0 results. I actually have
Zero errors.
0 error results. Yeah.
So now, were you always requesting the same page, or were you randomizing them?
We were requesting the same page with the specific, we did multiple tests. The ones that I kind of included here were just the main ones we did. I kind of played around with it, played with the numbers and saw what we got. And this was kind of I found the best way to explain it. But I mean, I went all the way down from 100 requests up to like 3,000 and back and forth, and we saw where it was. But in the end, yeah, we were using all of the same actual addresses to
So
go to.
you're sort of ignoring the I/O process.
Kind of a little bit. I mean, we tried to, with Raspberry Pi, we used Nmon Analyzer to go in and see what was going on with the CPU and the disk write usage and all these types of things. And when I was working with Professor Burma one day, I'm not a computer science major, so a lot of this sometimes was going a little bit over my head. So I would go work with him, and we kind of found that within the software of Raspberry Pi that it had a limit to how, I can't remember exactly what the determination that we came to, but there was a limit to how many it would handle the firmware itself, how many people could be connected and be trying to get onto this processor. So again, this is more so looking at processor speeds, and what I really think it comes down to is the software and how the system itself is built. For example, Rachel is very simple. It's just HTML links to here and there, a couple videos, things like that. It's not difficult to use, and it's not very content. It's a lot of content, but it's not intensive content. It's not like we're trying to run Moodle or some type of.
Well, it's all static.
Exactly, it's all static. Yeah. But you'll see when we get to a couple other options, because we didn't want to just look at Rachel, but Rachel is if I went back to the weighted scoring model, we'll see that we gave it kind of a low score on content because it's really just what they give you. Whether it's in English, Spanish, I think they have like French now, but there's so many languages they're missing, and it's somewhat difficult to update and add your own content. So that's why we looked at other solutions as well, and that's when we came to LibraryBox. This is a Kickstarter project that was started a couple years ago, and a guy basically, his name's blanking on me right now, but I have, again, references in the end. He created software to essentially turn a TP-Link router. It has to be TP-Link. He gives you a list of routers that you can use for this. And what it does is basically turn it into, much like a Raspberry Pi device, a little hotspot that can give out a signal. The same thing with this guy. This guy could actually handle more, we found, than the little Wi-Fi dongle on the Raspberry Pi. It can handle about 12 to 15 people on it at once before we started getting server errors on our tablets and phones. We ended up using, I believe, not this guy right here for our testing. Basically, there were some differences. Some of them you needed to plug into power. Some of them had battery. So there's all kinds of different options there. The one that we used had a battery pack in it, and it just plugged in and powered through micro USB. So it was a small little device. Essentially, it just needed a flash drive or a memory card as well. And it also said that it could easily run off of solar power. And they just, on their website, they recommend, if you want to use it out in a place where there's consistent power and you don't want to corrupt the flash drive or the memory card, that you keep it on power at all times or you power it down properly. And these are the results we got with LibraryBox. So we'll see they're actually quite different. As 1,000 requests. So again, it is one guy apparently working on this, and I again think all of this comes more down to the software and how the information is distributed from the server. So his software was basically, I I thought of it as kind of like Google Drive. I mean, basically he had 4 folders, whether it be video, audio, the different types of file sizes, documents, things like that, and you would just drag and drop whatever you were looking for. So we did, just a Word doc, a random Word doc. We did a PowerPoint, and then we put an EPUB in there, and our average failure rate. And this isn't a whole lot we're trying to pull from it. They aren't big files; they were all less than a megabyte, and the failure rate was still pretty high. 11% was the average on just 1,000 requests. I probably should have included maybe like 100 in here or something like that as well, because we would see that this failure rate did go down quite a bit once we got down to 100. Expected amount. I mean, again, we're not going to have 1,000 people running off a tiny little library box server. And this is 750 requests, so just a few less. We see the error rate drops a little bit more. This one we also took out one option, which I believe was the EPUB. Yeah, the ebook. So we just compared it to just 2 different things. To keep things static, we probably should have compared them to 3, but we got close to our error rate average. So we kind of liked LibraryBox just for something that customizable solutions. I just want to put a book on here. I just want to put a PDF and show it to my students, get them to be able to access it on their laptops. Not really a full, learning system or a full archive, kind of like Rachel was. Go ahead.
So in LibraryBox, you can add your own content. It comes blank.
Mm-hmm. It comes totally blank.
The other one comes with content, but you can't really, unless you go mess with it.
Yeah, you can add to Rachel's stuff. There's a link where you can go create, where you can upload stuff to the flash drive. One thing I didn't point out about Rachel that is kind of important is very, very difficult unless you already have that memory card with all the information on it to get their database. It's a 32 gigabyte file. That was my original issue. It took me almost like 2 days to figure out how to download directly from their server. I ended up having to FTP into their server to download it. Failed a couple times. So, I mean, again, realistically, if you were to go do this in a country without reliable internet or power, they wouldn't be able to download this file. So you would have to, it's something that would have to be put on memory cards first and then distributed from there. LibraryBox, again, is a little simpler. I mean, you could have a really old computer somewhere that you can just stick a flash drive in, drag some files into a folder that you want to show everyone and share through this hotspot, and stick that flash drive into the TP-Link router, and then boom, it's working. So we like that option just because it's a little more open, it's a little bit easier. And then this last one just was kind of sprung upon us. Bob Marsh, which is the engineering director at Infinio, asked us to take a look at this for him too, because apparently Intel had just given them this device to try and test out and see what they thought about it. It's called the Intel Education Solutions Access Point, and it is a much, I want to say, cleaner or much more developed system, as you would expect from Intel, than World Possible or LibraryBox and some Kickstarter project. It has a whole menu system where you sign in as an administrator and you can decide what your students can access and what they can't access, and you can upload all your own content, and they also have much of their own content, whether it be, again, piano lessons, math lessons, all these different types of things, videos, all that type of stuff. Although the main point and the problem of it, Intel never actually told us the actual cost of the device, but Bruce told me an estimated around $280 for it. And it needs constant power, and it also, when it's originally set up, needs Ethernet access. It can't be Wi-Fi or anything. It specifically needs to go through Ethernet, apparently. So not the best solution for rural areas, basically. That's what we came down to. But it is a cool little device, and it will have, we were connecting phones to it, and it never dropped off. So we didn't even get to a point where we were having failure rates with this thing when it came to connection. But when you see me trying to use JMeter on this next screen, with only 500 requests, same ramp up period. Let's see here, access 5%. 1 second. Yeah, so 500 requests, school, a very large school would be 500 students. You wouldn't really find this, in rural Africa or in any area that have smaller schools. But 5% error rate on just this access lessons page. So I'm pointing this out because when you use this device, the first thing you come to is just a list of lessons. It's the very first thing that anyone that connects to the device sees. And it's a very extensive web page. It has a lot of stuff on there. It's not just HTML, it's not just static. It has videos and all these different things. So as soon as we kind of bombarded that front page, we started to see failure rates. And we immediately in JMeter started to see a lot of things drop off. And you'll see quickly that as soon as I double it, just to get 1,000 to compare it to some of our other solutions, that error rate went crazy. 10 times. And it was specifically that lessons page. So, which you need, it's the first thing you access. So Bruce and I thought that was kind of interesting. We just commented on how Intel's more of a hardware company than they are really software, so maybe that has something to do with it. But essentially, this, from what we understood, the Intel Education Solutions Access Point was in its beta testing form, and it is not ready according to what we saw from it. But the interesting thing, when you get to a specific lesson, so this would be the URL for the overview lessons page, as I said. But if I got to just a math lesson or just something on a breathing lesson or anything like that, it was quick and it got it and it was able to bring it up. But if you wanted everything and you needed a list of everything, it would fail pretty quickly. So
that's a design flaw. I mean, they can fix that in art.
They can fix that, yeah. And actually, I think Bruce or Bob ended up emailing Intel and telling them, he ended up sending some of these results to them, just saying, hey, we were using JMeter, and the first page we got to, and particularly for the students, the administrator, because I said you have 2 profiles on that device, the administrator, you can bring that up, and it wouldn't be the first page you're at, but the students, as soon as they logged in, it would quickly start failing. So as we expected, and we were focusing on Rachel in the first place anyways, our conclusion was Rachel is kind of one of the best options just because it's such a small device, it's so cheap, and it still has a great amount of information on it, and you can still update it. The only thing though, again, that we realized, we knew this would be something to think about in the beginning of the internship, but in the end we really realized it depends on where you are. It's completely variable. I mean, if you're in a school in Israel or something that has 500 students and they have constant power and they have good internet, well then maybe the Intel Education Solution Access Point would be one of the good options. But if you're in a school that's only maybe 10 people, no internet whatsoever, and you need to run off of solar power, Rachel might be better. So that's the solution there. It also had the lowest error rates, as I said, whether you were accessing a main page or a specific lesson or anything like that. Any questions for me?
You go back to the slide with all the other ones, you know, that table.
The weighted scoring model?
Weighted scoring.
Yeah, and I can explain some of those other solutions as well. I remember quite a bit about them and why we chose not to use them.
Yeah, I'm just curious about some of the other ones.
And why we didn't go with them and stuff like that. And
so which one of these is the one that gets it from the satellite?
Outernet. Yeah.
Okay.
And go ahead.
No, I saw something on Invenio's Twitter feed a few days ago. That I think they just got the device, or
yeah.
Did you guys get it when you were there?
No, we were trying to. We were, as I said, we were in contact with Satara, and I were in mainly Satara was actually in contact with pretty much everyone on this list, trying to see, hey, can we get your device for free? Hey, can we try it out? We're students testing this, blah, 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 blah. And as I said, we really only got responses from a few, mainly OLPC people were the only ones that responded to us, or people who had some type of relationship with OLPC. But Outernet specifically, yeah, it's this tiny little satellite device. It actually seemed pretty cool, and you could, I signed up to be a beta tester with them when I was with Invenio, and Bruce asked me to do it, and Outernet actually never responded. I never heard back from them, so I didn't even get to test the device with them. But the thing we also didn't like about it was that it, if we see updatability and some web info, stuff like that, they had no information on the internet about it yet. I guess, you know, again, still in beta testing form, they didn't have much to say. And also the updatability. It's literally like DirecTV, but for education. Whatever they are broadcasting at the time, that's what you get. So if you what we found kind of odd is if they were going to broadcast like an algebra lesson or something like that, it would have to be at 1 a.m. at this time, and that's when you got the server, and that's when you got the feed. And you could record that. You could record that onto something, but it was just so cumbersome that we didn't really kind of see it being a great solution compared to the other things. And a lot of these guys, Library for All, Commonwealth, and Open Learning Exchange, had similar solutions, but just not enough info on their website. And I'm surprised actually that we even gave them these scores right here for web info support, because I remember for both these two particularly, we read about it. It said they had a solution. It said they wanted to do something, and that there was a Kickstarter and that there was money being built, but we never found anything about an actual product or something that they had actually come out with. So that's why we went with the ones we did. I want to see if they're, I thought I had on here, I was going to put a summary of all the costs of everything. But again, that's why we ended up going with the Raspberry Pi device, because you can get a Raspberry Pi device online for like 20 bucks now, the first one, or $25 or so, and a flash drive for even cheaper. So, and it's robust. You were also showing us all the hundreds of cases you can get for it. I mean, you can get waterproof cases and all these different things. You can't really get that for the Intel option. You can't get it for Library Box. So that's the solution that we found best. Yeah. Any other questions for me?
Do you have any sense of how much power the Intel solution was drawing?
Was using? No, we didn't really have a way to measure that. We you know, honestly, when we were doing this internship, I personally felt we spent way too much time on the research, on looking through all the different options. I mean, we literally spent, because we were only there once a week, so we spent maybe 4 weeks of this whole thing just looking at these different companies and trying to understand what they did and what their product was. And Bruce really wanted us to, test a lot more than we did, more than just the 3 solutions. We were hoping to get at least 5. But, and technically we did. I mean, we did do the Rachel Pi 2 device afterwards, and we did something else that didn't work out too well either. But he gave us a list in the very beginning, and many of these were included on here. And it was, from what I understand, things he was interested in, things he had heard about, possible solutions, and it ended up not really playing out perfectly just yet. So we still came, as I said, we still came to the solution of Rachel.
So Bruce has been here before. He used the Banana Pi, which is like a clone of that. Did you guys build?
Yeah, that's the other one that I was thinking. So we did Raspberry Pi 1, Raspberry Pi 2, and Banana Pi. Banana Pi, he had his own Banana Pi that he had been working on with Rachel, but he was doing something with Cal Poly San Luis Obispo, and he had worked on the essentially the what's the word I'm looking for? Yeah, the user interface for it, and he messed up some stuff in the coding basically. So we kind of dropped that one out because it continuously gave us error rates, and it was because of his initial issue with the user interface. So, but apparently the Banana Pi option would have been one of the better options if we had the interface working pretty well.
By better option, you mean equivalent to Raspberry Pi? Yeah,
well, better option as in apparently it had a faster processor. It had been, I believe, we literally only spent a day on it because it wasn't working very well. But
it has an interface with a hard disk, so that presents another opportunity.
You said it could interface with a hard disk? Right. Yeah, I didn't remember that. I mean, I knew it had USB ports on it and stuff like that. I didn't know it had the capability. It also had an HDMI port, so you could plug it directly into a screen. But I believe the Raspberry Pi device has that as well. So
and that is essentially, I mean, for the naive person, it's exactly a Raspberry Pi.
That's what I figured from it too, and that's what it kind of seemed like.
I don't have mine here, but if you just look at it, you wouldn't be able to tell the difference, except mine is in a box that says Banana Pi.
Exactly.
But the Banana Pi does have a faster processor than the Raspberry Pi.
Well, it's got a faster processor than the Raspberry Pi 1, but it's a slower processor than the Raspberry Pi 2, and you notice very little difference between the two. So I'm guessing by extrapolation that the Banana would be the same. In
fact, just to show you really quickly, let me see if I can bring this up easily. All PCs were completed research paper. We get to the bottom here where we did do, what's this?
Do you know which version of Raspbian you were using? Because I've heard that the most recent OS takes advantage of the extra capability of the new Pi, but the old one doesn't.
No,
And
this
so,
is the old one. This is the one that works on both.
well, I think the old one works on the new one, but it doesn't give you the advantages.
Right. So the one that they tested was the one.
The most
The old
recent
one?
No.
No, the older one, yeah. That's what I
Oh,
thought.
well, then
That's one
you're
thing.
not being fair to the Raspberry 2.
Okay, yeah,
So we're gonna have to bring him back as an intern.
that works for me.
Let him go.
But here you'll see, this is the Rachel Pi, the first Rachel Pi device, really quickly. Same, some of these error rates, blah, 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 1,000. That's when we kind of got back to where we were. But mainly focus on like this, the one Wikipedia page of the average. So then I'll go down to Raspberry Pi 2. So 3.7 and 2.3. 2.1 and 1.5. Yes, it was lower. It does have faster processors, so the error rates were a little bit less. And I believe we are accessing the same exact pages here. Algebra lesson, headline typing lesson. Yeah, we're accessing the same exact pages, but only slightly different error rates. So, and we
How
can
big a
see.
deal is it to run this test? Is it just a matter of plugging it in? And is it seconds?
It wasn't hard. Setting it up was a little bit difficult, but running the test is just seconds. You open up JMeter, you attach to the device, and just hit start, and it starts simulating a bunch of requests going to the.
Did you have to go back to be an intern to do that? Or can
You can do it whenever. It's super easy. I mean, I've been playing with it on my own over summer with different things, whether it be Amazon.com or just different things, and seeing how often it fails. Yeah, JMeter is really cool. It's a free program, and from what I know, it's used. Netflix uses it. A lot of like major companies use it as their load testing device,
In fact,
basically.
originally when we used it the first time, my student Ben Tran.
He did YouTube or something, right?
He used to work at YouTube, and his day job was to use JMeter to see how YouTube would perform and then how it would fail, which is kind of where it came from, and because he was doing this at work, so I can do this for the PC server and so on. So that's I think it'll make for a good workshop session for us.
Well, can I give one of you a Raspberry Pi and to run this test?
Sure.
The second one, the two.
With the newer.
It'd be interesting to know if it makes a difference.
Sure, yeah, I would love to. I also wanted to just kind of show, I have to admit, some of this I was a little confused on exactly what it meant, but we got a lot more information than just error rates. So this is really what we focused on here. But I mean, we got a Gaussian distribution line, throughput, and we got latency somewhere too, but we got a lot more than just the error rate, and seeing these numbers fluctuate with the different devices was kind of interesting. You explained to me what the min-max thing was, but I can't remember exactly what that was. But essentially, JMeter can do a whole lot more than just see error rates. You can have it put out a ton of information, and especially with Raspberry Pi with the NMON analyzer, from what I saw, it was difficult for me to get the results from the NMON analyzer into an Excel file that I could display. But you could basically do a command line into it and see all, if anyone's ever seen NMON Analyzer before, it would just show you kind of what the CPU usage was and what the disk write speed and stuff like that. And we actually found that when we were running like 1,000 requests on it, the processors, it was barely being even taken out. There's such simple pages that it wasn't using a lot of processor power. And that, I believe, is it. I'm waiting. I guess Bruce is in Micronesia right now setting up some of the Raspberry Pi devices. So he's going to look over our paper, and we're going to publish it with OLPC and put it online. And I'm sure, Professor Verma will be able to give you guys some of the links to be able to read the research paper if you like.
I know the plan is if anyone has to look through it and approve it, then they publish it on their side. And then, so Bruce and I have been talking about taking some of this, and in fact, work on a research paper in this space to look at some of these things, the methodology, the process.
it's interesting that there isn't more out there about it. That's what I thought was interesting when we were first doing the internship. I mean, if I were to go, I've mentioned this internship to a lot of people, whether it be people at work or just family members and things like that. And the idea of bringing little libraries to places that need education and need it in schools was like not even on their mind. It wasn't even a thought process, but it's so easy to do with such cheap materials that I'm surprised that it's not kind of like out there and a little bit bigger. And also I know Benjamin Tran's stuff, his stuff is all up online, everything's, open. So all of my stuff will be as well. I haven't heard from Satara, so I don't know what's going on with her. I guess she's doing well, but yeah. That's it. Any other questions? All right, thank you.